Okay, fourth graders, it is your turn. Today is Wednesday, October 9th, and you are continuing on. This is actually the last lesson of this Go Math chapter, chapter 5, lesson 6. And today we're going to be taking a closer look at some number patterns, okay? The point of today's math lesson, sit flat please, is so that you can make and describe different number patterns. But let's first talk about your problem of the day. Daryl is making a pattern for a quilt. This pattern shows 40 squares. Every fourth square is blue. How many blue squares are in the pattern? Okay, this little box on the side, it's like it read Miss O's mind. It says underline what you are asked to find. Another way to say that is underline what the question is asking. Go ahead and underline it. The question is asking how many blue squares are in the pattern. Then it says circle what you need to use. That means circle the important information. All the important information is that there are 40 squares and every fourth square is blue. Do you see how Go Math agrees with Miss O that you need to underline what the question is asking and circle the important information? If two sources say it, your teacher and your book, it must be true. So please do it, okay? A pattern is what we call an ordered set of numbers or objects, right? We can make patterns in life all the time, right? Ever since you guys were in preschool or in kindergarten, you've been looking for and describing patterns. Well, we can also make patterns in numbers too, using numbers, okay? This might be a new word for you. Every object or number in a pattern is called a term, okay? So we can find the answer to this question by using our pencils to shade in the squares that will be blue. Okay, we know that every 4 will be blue. So 1, 2, 3, 4. Let's count 4 more. 5, 6, 7, 8. So you're going to shade in 8. 9, 10, 11,
12,
13, 14, 15,
16,
17, 18, 19.
20.
What do you guys notice about the numbers you're shading in? 4, 8, 12, 16, 20. Garrett. They're all multiples of 4. Yeah, so go ahead and shade in all the multiples of 4. Then fill in the blanks. Which squares are blue? Well, 4, 8, 12, 16, 20, 24, 28, 32, 36, 40. So how many blue squares are there all together? 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. Okay, now what rule are we doing to go from 4 to 8? How did I move from 4 to 8? What did I have to do? Evan? Add 4. So the rule here is add 4. Okay, we use rules to describe patterns to tell you how to get from one term to the next term. So this rule was add 4. Does that make sense? When they said every fourth square is blue, that translates to add 4 to get from one term to the next. Fourth graders, if we look on to the next part, it tells us that the rule for the pattern is add 5. Okay? What's another way to say add 5? What's another way to say if the rule is add 5, what's another way to say that? Sanvi? Multiples of 5. What else? Skip count by 5. Okay, it'll only be the multiples of 5 if the first term is a multiple of 5, right? Because if the first term was 3, what would the second term be if the rule is add 5? 8, and neither of those are multiples of 5. But in this case, because the first term in the pattern is 5, then yes, they will be multiples of 5. So what would the next number be? 10, and then? And then? Then?
25,
Then?
30,
Then?
35,
Then?
40,
Then?
45.
Good. Thank you, Swarnima. Go ahead and fill in the other terms of the pattern. Then it says, what do you notice about the digits in the ones place? What do you notice? They all end in 0 or 5. What other patterns do you see? It says, describe the patterns using the words odd and even. What patterns do you see about if those terms are odd or even? Go ahead and talk at your table. When it ends in 0, then the number is even. If it ends in 5, then the number is odd. What's another way to describe the pattern? It says describe the pattern using the words multiples. We've already said this. All the terms are multiples of, good. All the terms are multiples So what this shows is even though there was one rule, and the rule was add 5, within that one rule, we could find other patterns. We found that there's a pattern of ones digits, 5, 0, 5, 0, 5, 0. Also, odd, even, odd, even, odd, even. Also, another word to describe this rule was that all the terms are multiples of 5. This time, the rule is add 3, subtract 1. So the first time we're going to add 3, and then this next term we're going to subtract 1. Then the next one we're going to add 3, then subtract 1, okay? So the first term is 6. What would the next one be? We have to first add 3. So what's 6 plus 3?
9.
Okay. Then the next part is subtract 1. So the next term is?
8.
Okay. The next one is add 3.
11.
Subtract 1.
10.
Add 3.
13.
Subtract 1.
12.
Add 3.
15.
Subtract 1.
14.
Add 3.
17.
Do you guys see how sometimes the pattern, it changes, right? There's 2 different rules. Add 3, subtract 1. Add 3, subtract 1. What other patterns do you see in the numbers? Go ahead and talk with your table groups. What other patterns do you see? In this game, your job is to guess the rule. Imagine that there is some sort of machine where I put one number in and it does something to it, and then a number is spit out. Okay, you have to decide based on the numbers you try and see what numbers come out. You have to decide what the rule will be. Okay, make sense? Okay. When the number 2 goes in, the number 4 comes out. Are you ready to guess the rule? Do you know for sure? Is there only one rule that it could be right now? What are some possible rules? It could be add 2. It could also be multiply by 2. It could also be plus 5 minus 3. You never know, right? So try some other numbers. What other numbers would you like to try? Sunvi. Okay, when I try 8, I get 16. Okay, Anushka. Try 7. Okay, when I put in 7, I get 14. Is anyone ready to guess the rule? Do you guys notice a pattern? What is the rule? Everyone? Yeah, multiply by 2. Okay, make sense how this works? Okay, let's try some more.